Alright everyone, what we're going to be learning about today is the transformations of sine and cosine. So the first thing that I want to go over is just what we've already learned. So it's always y equals this plus or minus a, where a is the amplitude of sine, and then b of x, or b times x. So this b is the number of waves in 2 pi, or you could look at it as the period, which is 2 pi over b. And then the c on the end, y equals c, is the midline. So we're going to be looking at the transformations in a slightly different wording today, but we're going to relate it back to the amplitude, period, midline, so on and so forth. Okay, so first thing we're going to do is state the transformation and graph this function. So as with any function, such as like y equals x squared plus 2, this is going to be going up 2. So it's going to be the exact same thing here. This is just going to be up 2. Okay, so we're going to go ahead and graph this function. So it's just going to be the regular sine of x function, which is this here, but this whole thing is going to be shifted up 2. So what we're actually shifting is this midline. We're going to move the midline up 2 and then keep the wave exactly the same up here. So remember, c is the midline. This is where up 2 is coming from, this plus 2. So the first thing I'm going to do is going to graph the midline, and then we're going to graph this function. So we're going to have 2 as the midline. The regular sine function starts at 0, 0, but now we're shifting it up 2, so it's going to start at 0, 2. Okay? Then the sine function comes back to its original position at 2 pi, but notice it goes here, then pi, then at 2 pi. So we're going to graph these 3 points. We just graphed the first one. Now we're going to graph at pi and 2 pi. So here, then at pi, and at 2 pi. And we can continue this back in the other direction as well. All right, now between the first 2 points here, it's going to go up 1, and then between the second 2 points, it's going to go down 1. So here, between the first 2 points, we're going to go up 1. Between the second 2 points, we're going to go down 1. So this one sine wave looks like this, and in the opposite direction, it's going to look like this. All right, so this is your one sine, or your sine function shifted up 2 units, which is also the midline here. So we shifted the whole thing up 2. And you kind of forget about this x-axis and make this your new x-axis. Okay, let's try another example. Okay, we're stating the transformations here, then graphing the function. So at the very beginning, we notice this negative. That just means we're going to reflect over the x-axis. Then we have this 3 in front. So 3 is usually our amplitude. That's how far up and down we're going. So here we're going to go up 3, down 3. But looking at our original cosine function, it usually goes up 1, down 1. So instead, we're going to go up 3, down 3. So this is actually stretching vertically. So it's making it taller this way. So this is going to be a vertical stretch by a factor of 3. Okay, now we're going to work with this piece here. So this 2 means that there are 2 waves in 2 pi, which also means that the period is going to be pi. So 1 wave is going to happen in pi, but 2 waves are going to happen in 2 pi. So usually 1 wave happens in pi, or 2 pi, or 360, but now we're saying 1 wave happens in pi. So we're actually shrinking the wave this way. So instead of going like this, we're going to go like this. Okay, so this is a horizontal shrink because I'm taking the wave and making it smaller this way by a factor of 2. Okay, so let's see what this looks like on the graph. Usually cosine starts at its maximum or minimum value. So the maximum or minimum value is going to be 3 or negative 3. But since we have a negative in the front, that means instead of starting at the max, we're going to start at the min. So we're going to start at negative 3 all the way down here. Okay. Now, cosine usually goes back to its original position in 2 pi. Okay, so usually here in 360. But now, since we're going to have 2 happening there, it's going to go back to its original position in pi, or 180. Okay, so it's going to go back to its original position right here. Okay, and then it's going to go back again in 2 pi. So we can go ahead and continue this in this opposite direction. Oh, and the midline of this function is just the x-axis because we're not shifting up or down any. Okay, so we're starting at the bottom at negative 3. And this purple graph here that I drew is actually negative cosine of x. Okay, so this is what we're going to be referring to. Starting at the bottom, then it goes up, and then back down. So between these two bottom points here, you're going to go up to its maximum value. So between these two bottom points, we're going to go up to the maximum value, which is positive 3. It's going up 3, down 3. And then same here. Between these 2 points, it's going to go up to positive 3. And we can continue this back in this direction as well. Okay? So it's going to go something like this. Up, down, up, down. But between these 2 points, it's going to cross the x-axis. Okay, so here, between these 2 points, it crosses the x-axis. So it goes up through that point and then down through this point. So between these two, it's going to be crossing and crossing again here and here. Okay, so let me show you what this graph looks like. Up, down, up, down, and back up. And we continue on like this for a while, forever actually. And then in the opposite direction, up, down, up, down, and then back up. Okay, so this is our new function of cosine. So here was one wave of cosine right here. Okay, so one wave is happening in pi, which means that 2 waves are happening in 2 pi. Okay, so that was our 2 waves there. It's now going up 3 and down 3, and it's starting at its minimum point because we're reflected over the x-axis. Okay. I don't want you to worry about graphing these functions. It's more of something that you do in pre-calculus, but I might have you matching up these functions with their graphs. What I do expect you to know how to do is to write out the transformations. So we're going to move on to what you're more so going to be doing for your practice, which is stating the transformations. Okay, so for this first example, we're first going to start with this 4. This is usually our amplitude, so instead of going up 1, down 1, it's going to go up 4, down 4. So we're going to make it taller in this direction. So it's going to be a vertical stretch by a factor of 4. Then here, this means 3 waves are going to happen in 2 pi, so it's going to be happening much faster and shorter this way. So I'm shrinking the size of the wave so that more waves can fit in 2 pi. So this is going to be a horizontal shrink by a factor of 3. Okay, and then the last thing is this number on the end, which is just down 1. Okay, so let's do another example. First thing we're going to look at is this negative in the front, which just reflects over x-axis. So for example, for the cosine, that's just starting at the bottom instead of at the top, and then going the opposite direction. Then this 1/2, instead of going up 1, down 1, it's now going to go up 1/2, down 1/2. So instead of going here, it's going to go here. So I'm actually shrinking it vertically. I'm making it shorter. So this is a vertical shrink by a factor of 1/2. And then the last thing here is this 1/4. Okay, so instead of one wave happening in 2 pi, 1/4 of a wave is going to happen in 2 pi. Okay, so here, one wave happening, now it's going to be one wave happening. Okay, so I'm stretching out the wave horizontally. I'm going to make the wave go from this to something like this. Okay, so I'm going to make the wave happen much slower. Okay, so this is going to be a horizontal stretch by a factor of 1/4. Okay, and now we're going to do our last example here. First thing, there's a negative in front, so we're going to reflect over x-axis. And then we have this x over 2 here, okay? But what I want to do is actually rewrite this. So x over 2 is really the same as y equals negative sine of 1/2 x. Okay, so this 1/2 x is really what we're going to be comparing it to, because 1/2 times x is the same as x over 2. Okay, so here, now we can see that this is a horizontal stretch because now instead of one wave happening, it's 1/2. So instead of this, it's going to be like this. Ooh. Much slower. Okay, so we're going to take this wave and stretch it. Okay, so this is going to be horizontal stretch by a factor of 1/2. Ooh, that's pretty sloppy. 1/2. Okay, so again, you guys aren't going to have to worry about graphing as much as you are writing out the transformations. Hopefully you guys don't find this too hard, but if you do, please message me in their mind. I'll be very happy to help you. Hope you guys have a great day. Bye.